right, example number 2. A group of college students were selected at random and their ages were recorded. The table shows a summary. So we've got a table right here. And we've got number of students, in other words, just frequency, and then cumulative frequency. So you're building up. So we start with 3, and then we next had 72. Well, 72 added to your 3 gave us 75. 62 added to your 75 gave us 137. 31 added to your 137 will give us x. And the first question it asks us to do is to solve for x and y. So I know that 137 plus 31 equals 168, and that is my x value. Going through and looking at the pattern, I notice that my final total here is missing, and I know that I would obtain that by getting my frequency and adding it to my previous cumulative frequency. So I would take 194, add 6, and get 200. And there you go. How many students are younger than 21? This is where your cumulative frequency comes in, because now you're looking at not just a specific interval, but a grouping of high, low, medium values. So younger than 21 means that we do not include 21, but we want to know what the total is below 21. Well, thankfully, we have cumulative frequency at 20, which means all of the students leading up to that would be 168. So there are 168 students who are younger than 21. So this is a very typical IB question where they ask you to solve for something in a very mathematical way, and then they ask you a question which you actually technically already solved for, but they're checking, hey, do you really understand what this number means and why we would use it? So this is you just saying, hell yeah, I know why I use that number, and here's why I would use it, because I'm talking about grouping a certain section of the data together. Now we're talking about the percentile. So up above we were talking about percentile. Now we have to find it. 25th percentile means the 25th percent of your total students. A little dyslexia coming through. There we go. Of your total students. 25th percent of your total students is 0.25, 25%, times total students, which is 200. So your 25th percentile is 50 students. So you need to figure out, where do your first 50 students lie? So 25th is always at the bottom. It talks about the bottom of the range, but really that just means like at the beginning, right? So we talk about 17 is younger than 18, 17 comes before 18. And so it doesn't mean that it's anything worse that you're at 17. It just is at the bottom of the percent. So where does my 50th student lie? Looking at your cumulative frequency, you start with 3 and then you jump to 75, which means that my 50th student happened in this interval, which means in this interval is where my 25th percentile lies. So 50th student happens in 18 interval, which means that the answer is 18. Find the value of the 25th percentile. The value of the 25th percentile means at the 50th student, the 50th student is 18, because the first 3 students are 17. Here, let me do it from your perspective. The first 3 students are 17, and then the next 75 students or 72 students are 18, which means that your 50th student happens at 18. So that is your 25th percentile. Which means that a quarter of your students are 17 and 18. At least a quarter of your students are 17, 18. All right. Last example for today. We're given another we're given another list of raw data, and it's the height of 30 students randomly chosen in a large school, and they're recorded. Is this data discrete or continuous? If we're talking about height, it has been measured, which means it is continuous. We're going to choose an appropriate interval and interval width and create a frequency and cumulative table to represent the data. So again, we're looking for numbers that are nice. We're between 0 and 2. So I wouldn't want to go by 1, right? Because between 0 and 1 and 1 and 2 is only 2 intervals. So that's not really the number of intervals that we want. If we went by 0.1, 2 divided by 0.1 is 20, and that's too many intervals. So we want to do more than that, And so if we did maybe 0.2, but I think 0.25 is a little bit nicer, and 0.25 and 2, 0.25, so 2 divided by 0.25. In other words, how many times can 0.25 go into 2 is 8 intervals. And that's a really nice number of intervals to go into this. And think about it, that my lowest number is 0.92. So I wouldn't really do 0 to 0.25. I wouldn't really do 0.25 to 0.5. I wouldn't even do 0.5 to 0.75 because I would have 0 for all of those numbers. So I'm actually going to start with 0.75 to 1 as my first interval. So let me show you what I'm talking about. We've got height, which is measured in meters. We're going to do frequency. And then we are going to do cumulative frequency. We're going to run out of space, but that's okay. So we're going to start with 0.75 and go up to 1.00. We are not going to include 1.00. Again, try and think about your grades, right? 80% would be in the B, the next level up. So we're going to include that 1.00 in the next level up. And then do 1.25, 1.25 to 1.5, 1.5 to 1.75, and squished in here, 1.75. And I am going to include 2 in that last interval because it's the end, so I'm going to include it in the rest of the interval. It's a slightly different measured interval than the rest of them, but in this case, it's okay. So now we need to look at the frequency. How many numbers happen between 0.75 and 1? In other words, how many numbers are under 1? And I see that there's only one number that is under 1. And I'll cross it off. All right, now I want to talk about the numbers between 1 and 1.25. And I see this guy right here. This guy right here. And that's it. Go ahead and find the rest of these guys, and we'll go ahead and compare notes. Okay, so now we have our frequency for these ranges, and now we're going to go through and make our cumulative frequency. So we start with 1, and then we just add in the 2 that we then count up. So now we've got 3, and then we add 3 to 6, 6 to 13, 19, 19 to 11, and we've got a total of 30 students that we counted in this. We're going to use our table to summarize the data in a short paragraph. By that, I mean a sentence. So we're going to look at this and see, okay, what can we determine, what can we conclude with this information that we've got? Well, we've got not a whole lot of students represented in these height ranges, and I would say that the bulk of our information is happening right here. So between 13 and 11. So we've got most students who are 1.5 meters and above tall or in height. Since this is talking about like a range at the end of our data, I would like to talk about what the percentile is. So if we add up 13 and 11, if we add up 13 and 11, we get 24. And if we do 24 divided by 30, we get 80%. Which means that 80% of our students, of these students, are 1.5 meters and taller. Which means that our 20th percentile is at 1.5. So you can say 20th percentile is 1.5. Actually, let's go ahead and use our class midpoint to determine that, and that's going to be 1.25 plus 1.5 divided by 2, which is 1.375 meters. So there's lots of different ways that you can then take this data and interpret it and put it together. Frequency tables are just beginning. We're going to talk about histograms to get a visual representation the next time you have notes.